the product is transferred from the non-sterile zone to the in-feed zone for electron beam irradiation. At this time, the products are conveyed one by one into the bunker, led by a polystyrene phantom including a film dosimeter. Moreover, an automatic labeling device gives each product its own barcode. At the same time, a radiation indicator is attached for distinguishing which products have undergone electron beam irradiation. When the sensor located on the entry platform of the automatic production system reads the product barcode, the first process record is created and the product can be continually traced and managed. Now the product arrives at the bunker, which not only accommodates the irradiation chamber, but is also a concrete maze that protects the product from X-rays. Each product is supplied into the bunker in specified intervals by a blade stopper to prevent interruption between the products in the irradiation chamber. The conveyor is constructed in multiple stages to guarantee flawless processing and high productivity. Speed adjustment is possible in each stage, and product tracking sensors are installed at strategic points. The advantages of using electron technology can minimize the material degradation of the product due to the high processing speed and the efficient extermination of bacteria and microorganisms. Although it radiates the same amount of radiation energy, it is more than 1,000 times faster than the competing technology gamma, and it does not produce any residues from EO sterilization or radioactive wastes from gamma sterilization. What you are seeing now is a 10 mega-electron-volt linear electron accelerator operated by GEV Co. This accelerator, manufactured by MEVEX in Canada, creates thermal electrons in the cathode and emits them into a cylindrical cavity called an accelerating waveguide. Here, RF electromagnetic waves in the S-band domain are formed, which accelerate the electrons up to 10 mega-electron-volt energies through the scanner. A bunch of electron beams spread and are diverted over the products. The product has now arrived at the actual treatment point. The electron beam is diverted right and left by scanning magnets and passes over the products in a vertical line. The scanning frequency of the electron beam is approximately 3 times per second and is linked to the speed of the conveyor to guarantee dose uniformity within 5%. Here, electron particles from the electron beam accelerator are being sprayed into the material of the product. The particles destroy the DNA structures of bacteria or microorganisms embedded on the surface or inside the product, thus quickly and effectively exterminating toxic substances. There are more than 3 monitoring dosimeters on each route that are irradiated along with the products. The radiochromic film dosimeters inserted in the Phantom show an increase in scarlet density proportionate to the irradiation and are analyzed in our dosimetry lab upon the completion of the irradiation process. Now we can see a B3000 series film dosimeter being discolored by irradiation. Directly underneath the accelerator is a separate underbeam conveyor. This is a device specially manufactured by MEVEX that can be operated at a low speed with a high degree of accuracy, which can irradiate accurate doses up to hundreds of kilogray at once. The dose is adjusted by the speed of the UBC. If the speed is high, the product receives smaller dose. Products that have completed one round of irradiation are coming out to the outfeed zone. The barcodes of the products that have just come out are read, and their processing histories are recorded. These are then compared with the product specifications in the database, after which the next process signal is sent to the automatic system. A turning machine that can flip the products with various sizes and weights has been manufactured for the safe and efficient handling of them. Products that require irradiation on both sides are rotated 180 degrees by the turning machine and irradiated through the same process, and are discharged through the outfeed conveyor. When the irradiation process has been completed, the phantoms are retrieved. The response, such as optical density of the dosimeter, is measured by a suitably calibrated Genesis 20 spectrophotometer, and the absorbed dose is calculated. The absorbed dose is reviewed by one of our qualified technical staff, and if it fulfills the requirements, an irradiation certificate with the processing results is issued to the client. The entire series of processing histories can be tracked and checked using the barcode attached to the product as well as the control number on the certificate.